In this video, we'll be going over trees in data structures and AP CS. So I will show you the tree, we'll trace preorder, trace inorder, trace postorder, and we'll also go over the Java code to generate all traversals for each of these examples. So let's start off with an example where we have to have a tree like this. So let's say we have A, so this is a completely filled tree. And first, we want to find the preorder. Let's quickly write a reference for what a preorder is. So as a refresher, it's when you go from root to the left to the right. So let's trace this tree first for preorder, then we're going to do it for postorder, and inorder, then we're going to do it for postorder. So for this, let's start off. First, we have to start at A. So we're at A. So once we're at A, then we go to B. So for A, we first will write down A. And then when we go to node B, we'll write down B. So we're at B. So then after we go to the left to B and have visited it, now we have to go to D because it says we're going left. So we'll keep going left. So we're at D. And then after we're at D, we visit D. And since we know that, so we can look here and we see that there's no children. So you can see no children. So that means you have to go back up. And then that's why you mark the D. So on your second time when you visit it, you see that you have nothing else to visit down there. So you go back up. So then now you have to go to B. So at B, we can go down to the left. We already went left, So we go to the right of B, so we go to E. And then we see that E, it also has no children. So because it has no children, we already visited E. Write down E. So we go back up to B. So now that we're back up at B, we can go back up to A, and now we go right to C. We'll keep the color actually. So now we have visited C. So after we're at C, then we go left to, I'm gonna change the color. We go left to F. So now that we're at F, we can write down F. And then after this, we go back up to C, and then we go to G. So now we can do infix. And here we can also see that these ones point to nothing, they're null, which is why you didn't traverse down and up. So you can kind of just like stop there. You don't have to draw those line things. So let's do infix. Actually, I don't like how I wrote these. I want to write them underneath. Okay, that's actually one string, so actually we'll just keep it like that. So for our next tree, we're gonna go over infix. So when you have infix, this is when you go from left to the root to the right. So what this means is we're gonna start at A. So at A, then we have to go, we're going left. So we go left to B. So then we go left again to D. And now that we're all the way at the left, we can write our first node in our output. So I should have written this is our output over here. So after we're at D, now we see that D, it has no left because it's null. Also I guess you can write these all here too. We'll do this. Just when there's no children, it always has a null left and right subtree. Okay. So after this, you can go back up to B. So we have visited B. So now we can print B. So now that we visited B, we can now go right. Or we went to the root and then we went right. So D, we went up to the root, which is B. And then B, we're going to the right, which is going to be E. So we went to E, but you know, there's nothing down there. So you go back up to E. And then now that you visited E, you can print E down there. So now that we're at E, we got to keep going up. And then we already visited these, so you can go down here. E, we visit A. So now that you visited A for your second time, oh, wrong one. You write A here. So now we go right. So right, we have C, and then we go left. So after we go left, we're at F. So at F, we go down and we see there's nothing there. It's null. So we go back up to F. So that's why we can print F. And then we continue this pattern. So you go back up to F. You're back at C. And then you visit C. That's your second time visiting C. So you can print C. So now that you're at C, you go to the right, which is G. And okay, I'm gonna change the color. And then you go down. There's nothing there at the null. So you just go back up to G. So then that's your second time visiting G. So that's like G. So that's it for the infix traversal. So now we can do Postorder. So when you have Postorder, you're going to go left, right, to the root. And we'll do this for this last tree over here. It's kind of far away, so I'm just going to like write it over here. So what you're going to do is we have to start at A, just like we have with all the other ones. So you're going to go left, and you're going to be at B. And then remember, so postfix is left, right, root. Left, right, root. So we're going left first, and then we're going to go right, and then to the roots. So on the way to the left right now. So A, we're going to B. And then after B, we're going to go to D. And we're visiting D. So we can write D here as our first thing that's output. And then after this, we have to go right. So we're going to go to E. It was actually weird. E. So then you're at E right now. And then now that you're at E, you can see like down there, there's to the left, there's nothing. So then you visit B. So you have E here. And now you go back up to B. So now that you're up at B, now you're going to go to the right, which is C. So we can write B down. So that's, and to the right, that's C. So at C, you're not going to write C down yet. So now you have to go left. So left is going to be F. And then we go down F to the left. Because this is postfix, we're going left. And we see there's nothing there, it's null. So then you go back up to F, and that's your visiting F. So basically, I want to write this down. So a rule is write the node in the output once you visit it, not pass it. Okay? So where are we? We're at visit F. So after we visited F, okay, we have F in our output. So now we can go to our right. So our right is going to be G. So once we visited G, we want to go left, right? But there's nothing there. So then we go back up to G. So now that we went back up to G, you can print that. So after G, we're still on G, right? So then now you can visit C, because you're going to go left, right. We already tried to go left. There was nothing on the left. There was also nothing on the right. So you got to go back up to the root. So now you're at C again, right? So you can visit C, and that's your second time visiting C. So you can write, that's your second time on C. So that's your visit, not your pass. So after you're at C, now you're just going to go back up to the root again. And after you're at C, you're going to visit A, and that's your second time on A. So then you print A at the very end. Okay, so that's it for our first example of the tracing the traversals. So now after this, let's look at our code for this traversal. So here we see that we have class node, char data, node left, node right. We have node character data. This dot data is equal to data. Then you have public class tree traversal. And here's the code for the preorder. So it's going to be static void preorder node root. So we check if our root is empty, and then return. We have system.outprint the data in the root and a space. That's how we would have printed it out. Like our code that was in our post order, we have a space in between each of them. Then we do preorder root left, preorder root right, in order, yeah, static void in order node root. If root is equal to null, return in order root.left, system.outprint root.data plus space, in order root.right. Here you have post order static void post order node root. If the root is equal to null, then you return post order root.left, post order root.right, system.outprint root.data plus space. Okay, so now let's do our next example. So for our next example, we're gonna do, instead of this tree, we had just letters in it. Now we're gonna do an expression tree. Expression tree. So for our expression tree, we're gonna have a root of times. Then we'll do a plus, and let's do a minus over here. And then you have a 3, and then you have a 5. And then let's have a 10 over here, and then let's have a 2 over here. So our code that this is going to represent is the expression of 3 plus 5 in parentheses times 10 minus 2 in parentheses as well. And you can kind of see this here. Like when you have your expression in real life, you can see that it kind of like it corresponds to the tree. Like if you just look at it from left to right, you see that when you're going left, you have 3, and then the next encounter is plus, and then you have 5, and then times, and then 10 minus 2. So it kind of makes sense. It's really like when you're drawing out the tree, when you have the expression, you're trying to get the tree, it's pretty simple. And also when you're going from the tree to the expression. So that part's straightforward. The part that's a little harder is, again, going from finding your preorder infix and postfix. So for preorder, again, that is your root, left, right. So let's duplicate this, or I'm just gonna put this over here so we have some space. Yeah, so kind of small, 3 trees like this. Okay, so first you're gonna visit your times, and your times is gonna count. So you have your times there because you have your root. So then you go left. You're gonna go left, and then you're gonna visit. That counts as your visit, so we're gonna put that out as well. And then you're gonna have your 3. You're visiting. Go to left again. You're gonna visit 3, and just put that 3 out there. And after this, you're gonna go 5. So you have to go up, and then you're gonna. So for the rest of this preorder, you're gonna visit 5 over here on this tree. We're on this tree right now. So here you visit 5. After you visit 5, you go right to the minus. So once you're on minus, then you go to visit minus, and then you visit 10, and then you go up again, and then you visit 2. So now on your next tree, you're gonna start off the root. You're at the time symbol. So then on your time symbol, you go right, and then you go you go left, and then you go left again for infix, and then you go back up to plus, and then after you're at plus, then you go down to 5. When you're down at 5, then you have to go back up because you wrote down 5 here. So now you go back up. Now you're here at times. So this is your second time visiting times. So it's gonna be like this. So after this, you're at times. Now you have to go right. So going right, you're at minus, and then after you're at minus, you're now at a root. So when you're at your root, then you go visit 10. You're gonna go left. So you can go left. So now that you're at the left, you're at 10, you go down, you try to go left, but you can't go left anymore because it's null. And you go back up to 10, and you try to go right, but you can't go down to the right because it's null. So then you go back up, so then you go back up to the root. So that's your visit on 10. Now for this, you go back up to minus. So that's your visit on minus. And then you go down to 2. Or we'll change the color for this. Go down to 2. I actually want to change this to be like a darker purple. Down to 2. So that's going to be here. And then you try to go down to 2, but you go back up to 2. And then you try to go down to the right, and there's nothing there. So 2. And what you can notice about infix is that for this one and also for this one, or mainly for infix, when you have an expression tree, it's going to be the same thing as this expression, just without the parentheses. So here, this is without parentheses. So that's how you can double check your infix. So if you have your tree, you can easily get your infix this way if you have an expression tree. And also if you have your expression, you can easily draw out the tree using just your given expression. So now we can do postfix. So for postfix, it's always left, right, root. So again, we can start off here. We're gonna go here, we're gonna go left, left. We're at 3. Now we're at 3. So then you go to the right. So we went as far left as we can. So we try to go left. We can't go left, so we go back up. And then we try to go right. Can't go right, so you go back to the root. And here we can't go left or right, so we go back up to the root again. Here we already went left, so we can't go left anymore. Oh, we already went left. So then we have to go to the right. So the right is going to be on 5. So now that you're on 5, you can write down 5. So you try to go to the left, there's nothing there. So you go back up to the root 5. Then you try to go to the right, there's nothing there. So you go back up to the root 5. And you go back up to plus. Draw this with plus. So that is your visit on plus. Now, after this, you're on plus. You've already went left and you already went right, so you keep going back up. So now you're from plus, you go to times. And then you go to 10. You're going to go to 10. So you can write 10 here. And then after this, you can go to the right. So that's going to be your visit to 2. So that's your 10, 2. And then after that, you're going to go visit, you're going to visit minus. And then you're going to visit 2 times. Now let's look at the code required to build this tree. So for this tree, you have node root is equal to new node times. And then you have root.left is equal to new node plus. And then you have root.right is equal to new node minus. So this basically, you're declaring your root as this value. Basically, this is how you build the tree. So you store that plus inside of the node. And then on the left side, you store that plus, or you first store that times, and you store your plus and your minus. And then you, based off of your definition of left, you're defining another point on the left of that left. And that's going to be the 3. And then for your root that's on the left, which is the plus, on the right of that, you're going to define 5. And then it's the same process for the right as well. Now, after this, let's look at our last example. So for our last example, we're going to have an unbalanced tree. Unbalanced tree. So what this is going to look like for us is we're going to have an 8 here. You're going to have a 4, a 12, sorry, an 8, 4, a 12, a 2, a 6, and a 7 here. You're going to have a 14 there. So for preorder, again, this is root left to the right. So what this is going to look like is you're going to have your preorder 8. So you're going to first print your 8. You're going to have 8. So after 8, you're going to go left. So that's going to be 4. So then after that, you have your preorder 4. So then that's going to be, now you're on 4. So that's going to be 4. and then you're gonna go left again. So then it's gonna be 2. And then after this, you're gonna have to go right. So after this, you go right. Now you're gonna go to 4. Because the bottom parts are null. Let's see, I'll just write that out. Because I kind of like to do that. So now you're back up at 4. So now you have to go to the right of 4. Because you already printed out 4. So on the right of 4, you have 6. So you're going to print out 6. And then it tries to go to the left. But it's going to be null. So then it's going to return nothing. So after that, we go back up to 6. And then we see that we have a 7. So after we see we have a 7. Oh, I don't like that. 7. Then we print the 7. And then we try to go to the left, but it's null there. So then we go back up to 7. And then we try to go to the right, but that's null. So we go back up to 7. So after that, we have to go back up to 6. And then we already printed out 6, so we skip that. We go up to 4. Then we go back up to 8. So now we're at 8, right? But we already printed out 8. So you keep going down. So now you're at 12. So this is our first time touching 12. So that's going to be 12, printed out. We go left, but that's null. So you go back up to 12. So now you go to the right. So that's going to be preorder 14. So on 14, on the left, change color. So on the left, it's going to be null, and then go back up to 14. So on the right, it's also null. So go up to 14. So overall, we just touched 14, and then that was it. Now, after this, let's do our in order. Let me actually move this down to our preorder. Store that there. And oh no, I forgot to copy the tree a couple times. Okay. Okay. So now we're going to do in order and post order for this tree. Now for this in order, what you're going to have is in order 8. So you're going to start with going left. Well, let's write out what in order is. In order is when you go left, root, right? So you're going to go to the left. Okay, yeah. Call 1 is you're going to go to the left. Then you're going to go to the left again. And then call 3, you're going to go to the left. You're going to go to the left again. But you see that call 4, you see there's nothing there. It's null. So then you just see nothing. So then after this, you're going to print 2. Because that's as far left as you can go. And then you go back up to 2, right? So then you see that on the right, it's going to be null. So then, yeah, you're like, okay, whatever. Let's go back up to 4. So then at 4, this is your second time touching. So that's going to be 4. And then after this, you're going to go right. So you have 6, right? So then you see on 6, you try to go left, right? Because your pattern is left, root, right? So you just went right. So now you try to go after right, you try to go back to left, but there's nothing there on the left. So then you go back up to the root. So then you go back up to the root, and then after you go back up to the root, you go to the right. So then you go back up to 6. Now after you go up to 6, you're gonna go to the right. So when you go back to the right, you try to go to the left now. And you try to go to the left, but it's null, but then you go back up to 7, again, your root. So then you can print out 7, and then you try to go right, it's null. So you go back up to 7, and then you return to 6, and then you return to 4. You already printed out 7, 6, and 4, and you go back up to 8. So that's your second time touching 8. So you're going to write 8. Now, after you've touched 8, you're going to go right. So you go right? So after you go right, this is your next call, you're on 12. So you're on 12, you're trying to go to the left. You see that it's null, so you go back up to 12. Now you try to go right this time. And on your time you're going to the right, actually, I should show that you're going back up to 12. sorry. And that's, you went back up to 12, so then you print out 12. So now that you're at 12, you want to go to the right. So going right, you have 14. In order 14, you try to go left. Left, it's going to be null, so then you go back up to 14. So that's going to be print of 14. And then you try to go to the right. Change color. It's null, so then you go back up to 14. But you already printed out 14, so like you don't need to do anything else. So that's just going to be this. So this is going to be sorted because this tree is a BST actually. So this is your sorted. And as you can see, it's 2, 4, 6, 7, 8, 12, 14. That's sorted. Now let's do our post order. So for post order, for our first call, you're going to have going to the left. So for post order, what you have is you go left, and then you go left, you go right, and then you go root. So now first you're at this node, right? 8. So you're going left. That's going to be, you're at 4 now. So then you keep going left again, and you're at 2, and then you're at 2, right? You try to go left, that's null, so you go back up to 2. You go right, that's null, you go back up to 2, so you're printing 2. Now you have to go to 4. You return to 4. So now you're at 4, right? So you go right. So you're at 4, you go to the right, that's gonna be 6. You try to go left, that's null. You go back up to 6, and then you go right. So now you're going right. You go back, you're going right. So then you go to 7. We see that 7 is gonna be to the left, is null, and then you go back up to 7. Then you go down to right, that's null, so you go back to 7. So then you you go back up to 7. Right. Oh well, I don't want to show that. Like you're back at 7, so then you well actually I don't know, I'll just show that 7 there. So you print the 7 and then you return to 6. So now that you've returned to 6 from here, you can print out 6 finally. So then you print out 6. So now after you touch 6 twice, you don't have to print anymore. You already printed all these. Oh, but now you touch 4 again. So then you print out 4. So then after you printed out 4, you go back up to 8. And then you're here on 8. So now what we want to go is to the right. So to the right, we're going to go to 12. So we go to the left. We see that's null. Back to 12. Now we go to the right. On the right, we see that it's at 14. So on 14, we see the left is null, and we see the right is also null. So then we go back up to 14. So you print out 14, and then after this, from 14, you return to 12. And then 12, you're going to return to 18. Or 8, I mean. So then you're going to have 2, 7, 6, 4, 14, 12, 8. And the reason why you need to remember some things for post order is specifically that the recursion, it finishes the entire left subtree before touching the right subtree. It prints after both children finish. So here's the code to build this tree. You have node, root, new node 8. Root to the left is new node 4. Root to the right is, or the right of the root is 12. It's going to be a node of 12. And then based off that definition, you have 2 Based off that definition, you have 6. Based off of that, you have 7, and then you have 14. So yeah, that's basically how you do this. And overall, just you need to remember those traversal rules that we just learned. Like, for example, you know, preorder, you're gonna have the root first, and then here you have the root in the middle, and then here you have the root last. If you have trouble memorizing that, just like remember at least the roots are always going to be in a line like this, and then on the left you're going to have, like, you can remember that the left is on the left, so there's going to be lefts here to fill in that, and then here it's going to be rights over here. And you can also remember that, like, each of them, they have to have L. It's a combination of root, left, and right. So then you just fill in the L up here and the R there. So if you need, like, if you're having trouble memorizing that, just remember like this. That's kind of how I see it. So